So she's a member of the China Academy, Scientific Academy of Science. Sorry. Okay, so that is very, and we stopped asking. So it's not that we couldn't get more. People are sending emails to us and said, could I be part of that? We are not asking anymore. We stopped after 3 months, and the rest, we had about 36 people. And then we don't want to have only people who are famous, individuals. We want companies, because companies are the ultimate customers of everything we do. So we need companies. Look here what companies we have. We have IBM, Microsoft, Ericsson, Huawei, China is the biggest competitor of Ericsson, Huawei. We have universities, Peking universities. KAIST is Korea University. Chalmers should be there, Chalmers Institute of Technology in Gothenburg. My own school, where I graduated. I was so happy that they said yes. It's too bad if my own school don't think it's good. Here we have a city in Canada. This is a big insurance company. Oh, you must have heard about Software Engineering Institute. That's the people who do SEMAT certification. So they are also here, and Samsung, and so on. And I have only asked these. I could have asked, if I had more time, we would have 100 companies, but I have not had time. So now we are working, getting job done. Okay, this is just so you give an idea. These are the people who really support it. And so basically the fundamental problems were that we don't have a good theory for software engineering. We simply don't understand what basics of software engineering is. So even if you teach it, professors teach software engineering, the only way they can do it is to take one method and teach that. So one method. So for instance, in Sweden, in one university, they teach extreme programming. Okay? So people learn extreme programming. And then they come out to the world and people say, extreme programming? No, 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 no. Other people, and because they teach Scrum. Okay, right now, these people are happy because people want Scrum people. The third university teach Kanban. So, I mean, this is, but the professors have never developed any software, real software. So, how do they feel? Standing there and teaching. I talked to one top professor in Stockholm, and he said first when I said, we need to do something, do you want to be part of this? No, 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 no. Our students don't complain. How often do you hear students complain? They cannot complain because they have no idea what they could get instead, right? And then he said, and they are quite happy with, basically said, they're quite happy with the sheet we teach them. You understand? They are happy with whatever they get from us. So why should I change? And so then I asked him, do you like what you're doing? Of course not. But I have to do it. So that is, I understand him completely, because he has no theory. He has nothing he can teach that is fundamental and will survive over Scrum, Kanban, and so on. That is what we need. We need something you can teach that is understandable, goes with logic, has a good mathematical foundation, so you feel comfortable, and then that is so fundamental that people can go with it in the rest of their life. So it doesn't change because there is new fashion. That is key. So the world, do you know that the world has a huge number of methods? Hundreds 100,000 methods. Actually more. That there are 100,000 methods is really not the big problem. The big problem is that you cannot compare these methods. You don't even know they exist. You cannot learn from one another. It's just done for one little group, and it's not good. On these 100,000 methods, there may be 10, 20, 30 that are acceptable. The rest is just homegrown work. So you can ask yourself the question, how can we develop so good software? Because we actually have a lot of good software. Software is the largest industrial sector. Nothing is as large industrial thing is as large as software. The problem, we don't see it because it's embedded in companies all over. But the thing is, how can we do that? Well, we work very hard. So even if the methodologies are bad, we get the job done. We don't care about which method our company has told us to use. We do the job. And in some cases, we are very successful in the industry. But there is a lot of development that is just waste. So, and that can be improved. So anyway, there are 100,000. The problem is not the large number. The problem is that we cannot really use them and learn from them and grow and add new stuff. If you have, for instance, in your company develop software, and now something new happens, a new trend. For instance, before people had SEMAT, they had their method, and now SEMAT comes. What are they going to do? You need a major rework to find out what you have to do. And it's not easy. And that will happen all the time. Okay. So we need to change this at the least. So in my own company, I should say that I actually have a company. It's called Ivar Jacobson International. I am not employed. I have, it's about 100 people, and we are in 8 countries, and we help big companies to improve their way of developing software. So many of the companies on the list are my clients, so they know that we can do this. In my company, we have done what we are talking about, so we know it works, we know it can be done. The big problem is, as I said earlier, well, it's a way of doing it, but it's not widely accepted. If it's not widely accepted, it will never penetrate the industry. So I decided, even if my company can make a lot of money on doing this stuff and take one client after the other, this is not good enough. You know UML? When UML was founded, I had a UML before, but I said, we need a standard. So I basically gave up what I had and the tools we had developed to create a standard for the world. And that was very, very important, because now we have only one modeling language of a standard. So I'm doing the same thing now. This is a similar thing. This will be a standard, I'll tell you soon. So how do we do this? Now you get the idea. First of all, this is probably something you didn't know. Most of you didn't know. But underlying all these 100,000 methods or more, there is something we always do, always have, always produce when we develop software. There's something very small. That is the common ground between all methods. So if you look for any methodology, I can guarantee you that they have these things that I talk about as common ground, even if they are not explicit. They can be in the head of people, but they have to do it if they develop software. And that was a really interesting observation, because in my previous life, when I did rational unified process, I was thinking completely different. Then I said, we need to find a framework which anybody can tailor to use to develop their own methodology. So the framework became bigger and bigger and bigger. Boom! It included everything you possibly could ask for. And then I said, you people, you can just take away what you don't like. Stupid. Really stupid. Because the job of taking away is so hard. To find the things that are the things you really need is much harder than add things on top of it. So now we say, we start in the other direction. Find that little thing that we always have, always do, always produce when we develop software. And we call this the kernel. You can say the kernel includes the essential elements of software engineering, because they are the things you always need to deal with, explicitly or implicitly. Implicitly meaning you have it in your head. So, because even if you have it in your head and don't say anything about it, don't write it, you still have it and you still have to deal with it. So that is, now we have talked about one concept in kernel. So here is the latest and greatest of a kernel. This is not my kernel. My company has a kernel, and that kernel has been working for 5 years, so we know it works. This is a kernel that is the current kernel worked out by SEMAT. So within SEMAT there are about 20 people working on identifying the kernel. And then you see this is only 7 elements, or is it 8? Only 8. Now there may be other kernel elements. This is elements that we have to deal with. These are things like you build a software system, that's what you have to deal with. The software system is the final product. That has requirements. You need to have requirements to build something. The requirements may be documented or not. It doesn't matter. You still have requirements. And the interesting thing is that requirements take on, all these elements have states. So you can think of them as they have a state graph inside. Each one of these elements moves from state to state during the project. So for instance, requirements start in a state when you your first work you do is to get them in the state scoped. Namely, this is the boundary of a system where the requirements will reside. And then at the end, requirements go through 5 states, and at some state it is completed. Another state they are implemented. The fourth state they are fulfilled. So this is very interesting. You can measure the progress of a project by just looking at the state. And every such state has a number of criteria that you can need to check. Is of these criteria fulfilled? If they are fulfilled, you enter that state. So typically there are about 6 criteria for each state.